Hi, everybody. Mr. Wyatt here. And today we are in topic 3, section 6, generate equivalent expressions. This is the last topic we'll be covering in this chapter, and then we're going to be taking an assessment in a couple of days on Thursday. Okay, and I'm pretty excited actually for this section because we get to talk about my absolute favorite math property. We've already talked about the commutative property and the associative property. We talked about the identity property, but the distributive property is my absolute favorite. I use it all the time to do math mentally, and it saves me a lot of times not having to do everything by hand, paper, pencil, or having to use a calculator. So I really like the distributive property. Let me explain what the distributive property is. Let's say I want to find the area of each rectangle and then find the total area of both rectangles together. All right, so if you're looking at the image on the left over here, we have our two rectangles, and to find the area of a rectangle, just take length times width. And so we have 4 times 3 here, which is 12. And then we could do the same thing with this larger rectangle here, length times width. 5 times 4, or 4 times 5. You can multiply either way because of the commutative property, which says you can multiply either direction and get the same answer. And 4 times 5 is 20. So that is the area of each of these rectangles. Now, if you want to find the total area of both rectangles together, you can take 12 plus 20, and we get a total area of 32. Now, we're not given a label on any of these dimensions, so I'm just going to put 32 square units. Whenever we're talking area, we're always talking square units. Now, what if I took these two rectangles and just slid them together, clicked them together, and we'd have one super rectangle or one big rectangle combined by putting these two smaller rectangles together. They both have the same width of 4. This one had a length of 3, this one a length of 5. I could add 3 plus 5 together and find 8 is my total length of these two rectangles combined. So if I want to find the area of this super rectangle, I have 4 times 8, width times length, and that equals 32. Notice that's what I found over here when I did them separately, 32 square units. So what does this have to do with the distributive property? Well, here I took 4 and I multiplied it by whatever 3 plus 5 equals. 3 plus 5 is 8, you know. But what I did over here is I took 4 times 3 and then I added to that what I found here, 4 times 5. And both ways, we ended up with the same result of 32. So 4 times this quantity, I always use the word quantity when I'm talking about something that's in parentheses here, that's being added or subtracted, the quantity. 4 times the quantity of 3 plus 5 is the same thing as taking 4 times 3, and then taking 4 times 5, and then adding those results together. That's the distributive property. How is this useful for us? How can this help us do mental math? Well, just very quickly, if I were taking, for example, 3, and I was multiplying by 59, let's say. Well, I can tell you what the answer is right away. It's 177. So how did Mr. Wyatt know it was 177, just like that? Well, what I can do is rewrite it as 3 times the quantity 50 plus 9, because 50 plus 9 means the same thing as 59. And what it does is it creates two easier multiplying problems, 3 times 50 and then 3 times 9. Those are very easy to do mentally. And then I'll just add those two results together. So that's 150 here plus 27 here, which does equal 177. I'm going to let you in on a little secret. I actually did it differently. What I did is I took 3 times 60 minus 1. Isn't 60 minus 1 equal to 59? It is. It has the same value. And so now I have 3 times 60, and I have 3 times 1. But now I'm subtracting instead of adding like I did over here. And I had 180, and then I took away 3 because 3 times 1 is 3 to find my answer of 177. So it's a nice way of doing math mentally, okay? Now, we'll spend more time on this later this year, so I don't want you to panic if you're looking at this and saying, I'm not quite sure I followed all of that. Or you can watch this video again as many times as you want. All right. And teachers, if you want to pause here and kind of go through and discuss these a little bit more, right now you can certainly do that. I think there will be time. All right. But we're talking about generating equivalent expressions today, specifically with algebraic expressions. And when you see that word algebraic, that just means algebra, we're going to be including variables in our expressions. So 9 times the quantity 4 plus 5 equals 9 times 4 plus 9 times 5. You're taking the 9, you're multiplying by the 4, and then you're multiplying by the 5. You're adding those results together. Or here you're multiplying 5 by 8, and then 5 times 2, and then finding their difference since it's subtraction here. That's the distributive property. I can show this with variables. A times the quantity B plus C. What does that equal? Well, we're multiplying A times B. We're multiplying A times C. And then we're adding those together. Or A times the quantity B minus C. You're multiplying A times B. You're multiplying A times C. But then you're subtracting those. You're finding the difference of those values. That's the distributive property. Oh, I love the distributive property. Well, not like I love chocolate cookies, but I love the distributive property. All right, so what does it look like when we're dealing with an algebraic expression? Here the directions say write an expression that's equivalent to the following. So I have 5 times the quantity of x plus 4. Now, I don't have all numbers this time. I have some variables mixed in. And again, we discussed yesterday how variables are things that can change. Vary means to change, meaning I could put lots of different numbers in for x. Okay? So when I have 5 times the quantity x plus 4, I'm going to take 5 times the x. I'm going to take 5 times the 4. So 5 times x, that's just 5x. 5 times 4. And then here I have plus, so I'm going to add these results together. Well, I don't know the result to 5 times x. It depends what x is. So I'll leave that as 5x, but then it's plus 20 because I do know 5 times 4 is 20. So 5x plus 20 is equivalent to 5 times the quantity x plus 4. These are equivalent or equal expressions. Now, I want you to show these arrows here, and I always like to pretend that I'm in a battle and I'm bombing the fort. So you're going to hear me say bomb the fort when I talk about using the distributive property. Some of you might think that's weird, but I know I'm weird and you do too. So it all fits. Anyway, we have 3 times the quantity a minus 7. I want to use the distributive property to distribute the 3 through this quantity, just like a mailman would distribute the mail and put it in each of the correct mail slots on his mail route. So anyway, bomb the fort. 3 times A minus 3 times 7. Okay, you want to make sure that you bomb everything inside the fort. So we take 3 times A and 3 times 7. Now I know what 3 times 7 is. That's 21. So 3A minus 21 is what I get after I distribute the 3 through that quantity. That's it. Let's look at another example here. 2.4 plus the quantity 3a plus 3.6. Well, this one's different because instead of times here, instead of multiplying by this quantity, I have plus. Everything's adding. And I can use the associative property to change my grouping. Instead of 2.4 plus the quantity 3a plus 3.6, what if I put 3.6 with 2.4? 2.4 plus 3.6. Put that in parentheses, and then plus 3a at the end. Okay? Because I know what 2.4 plus 3.6 is. They're both regular numerical values. 3.6, add 2.4. 6 and 4 is 10, carry the 1. Here we get 6.0 or just 6. So I have 6 plus 3a. That's equivalent to this up here. Now notice I cannot add 6 plus 3 together because I don't have 3 here. I have 3 times a, whatever that might be. We always multiply before we add, and I cannot multiply these without knowing what value I am putting in for the a. So 6 plus 3a is as far as I can go. By the way, the commutative property for addition says I can write 3a plus 6. That'd be the same thing. Both of these are correct. Okay? Let's try another one here. Now I have 6 times the quantity, 0.5n minus 6. Okay, so now I am multiplying 6 by whatever's in this quantity here. So I am going to bomb the fort, use the distributive property. 6 times 0.5n minus 6 times 6. All right, now 0.5n means 0.5 times n. So if you're taking 6 times 0.5 times n, you can use the associative property and just take 6 times 0.5. 0.5 is 1/2. What's 6 times 1/2? Or what's 1/2 of 6? Well, it's 3. So I have 3 times n, or just 3n, minus, and then 6 times 6 is 36. Dunzos. This has the same value as this. I have generated an equivalent expression. 6 times the quantity 0.5n minus 6 is equal to 3n minus 36. Okay? The more you do these, the easier they get. Now I'm actually going to go in reverse. And I have 2m plus 8. And now I want to rewrite it as some number times some quantity. So I'm looking at these two terms here. These are called terms. And I'm looking to see, do they have a common factor? Is there something I can divide into both of them? And both of them have an even number. I can divide them both by 2. So now in my parentheses, 2 times what would give me 2m? Well, I could put 1m there. 2 times m equals 2m. Plus, and then 2 times what would give me 8? Well, that would be 4. So I have 2 times the quantity, m plus 4. And you can test this by bombing the fort. 2 times m, there it is, 2m. 2 times 4, there's my 8. And pluses are in the middle here. All right, can I do that on this one? Now I have 3 terms. 9x, 3y, 12z, they're all separate terms. Do they have any common factors? Well, what about 3? 3 goes into all of these. I can divide all of these by 3. And so I have 3 times, well, this would have to be 3 times 3x, right? Would give me 9x minus 3 times what gives you 3? Well, 1y. 3 times 1y is 3y plus, and then 3 times what would give you 12z? Well, 3 times 4 is 12, and then times the z as well. So I have 3 times the quantity 3x minus 1y plus 4z. There we go. By the way, I could also write 3 times the quantity 3x minus y plus 4z. Instead of 1y, you can just put y, because I can see right there, how many y's do I have there? 1. So you can write it either of those ways, and that's fine with me. Okay, if you like showing the 1 there, show the 1 there. All right, so that's it for today, everybody. We made it in just under 15 minutes. Have a nice day.